Alright, so this is a quick video key for this worksheet, Concentration Math. You got this on Tuesday. If you didn't get this, then before watching this, why don't you take a screenshot of this or something, and then you can work these on paper before watching this video. I don't think you should watch this if you haven't attempted all the questions. Alright, well with that, I'll go ahead and get into this. So for these first 4 questions, we want to determine the molarity. So that's the concentration of each of these solutions. And I'm telling you that to do that, we're going to take the moles of solute that we have and divide by the liters of solution that we got here. So for this first one, we got sodium acetate. The formula for sodium acetate is NaC2H3O2. So to get the molar mass for that, I'm going to go 22.99 plus 2 12.01s, and then 3 1.01s, and 2 16s. And I get my molar mass to be 82.04 grams is 1 mole. And of course, the reason that I need the molar mass is because we're given 150 grams, but if I want molarity, I need to convert that to moles, so that's my first step. I can tell right away that it's going to be greater than 1 mole, so I should take my bigger number, 150, and divide it by my smaller number, 82.04, and sure enough, I get this to be 1.83 moles, and there we go. That moles right here is the moles of solute that I got from 150 grams. To get molarity, we need to take that moles and divide it by the liters of solution we got. So liters, we know that we have 1,500 milliliters, and I know that 1,000 milliliters is 1 liter. 1,500, that's going to be 1.5 liters. So there we go. We got our 1.83 moles divided by 1.5 liters. When we divide those two numbers, that'll give us our molarity. 1.83 divided by 1.5, I get 1.22 molar. That's the concentration, 1.22 moles for every 1 liter. I just decided now that I'm not going to do every single question on this. I think if you can do, I'll do 1 from each section or 2 from each section. I'll do A, and I'll also do, let's go with D. Because if you can do D, you can do C. And if you can do A, you can do B. It's just kind of getting reps in. For D, let's go 1.70 grams of silver nitrate dissolved in 1,000 mils of water. Silver nitrate, of course, is AgNO3. So to get my molar mass for that, I'm going to go, what's silver again? 107.87 plus 14.01 plus 48. Got my molar mass to be 169.88 grams is 1 mole. I have way less than that. I have only 1.70 grams, so I should expect this to be way less than 1 mole. And my calculator tells me this is 0.01 moles of silver nitrate. That's the first piece. And then I also know that this is 1,000 milliliters, so that's 1 liter. So to get my molarity, I'll go 0.01 moles divided by 1 liter to be 0.01 molar, and that's it. There's my answer. All right, let's jump down here to the next section. E. All right, what are we doing here? We're determining how many moles of solute are dissolved in the following solutions. Okay, so this is a little bit different. Now it's asking for how much solute do we have in these solutions. What I like to do for this is take my molarity there, and I'm going to write down what that means. I know that 4 capital M means 4 molar, and that means that there are 4 moles in every 1 liter. That's 4 moles of solute. In this case, the solute is NaCl. So there's 4 moles of NaCl in every 1 liter. Well, if I want to know how many moles are in 250 milliliters, right, that's going to be, what is that, 0.250 liters. How does that relate? How does this number relate to this number? It's certainly smaller. How many times smaller is it? We can see that it's a quarter, right? Multiply by 0.25 or divide by 4, right? So then same thing over here. We should divide by 4 or multiply by 0.25. And of course, that's just going to be 1. So that's my answer, actually. I got 1 mole of NaCl in 250 milliliters of 4 molar solution. Good. I'll do F as well real quick. We got 35 mils of 0.1 molar HCl solution. I'm going to start this the same way I started E. I'll say 0.1 moles of solute, in this case HCl, in every 1 liter. And then I don't have 1 liter here. I only have 0.035 liters because that's 35 mils. So I just need to scale that down. Right? I'll scale down by multiplying by 0.035. So I'll do that same thing over here. 0.1 times 0.035. And that gets me 0.0035 moles of HCl. And there's my answer. Yeah? Cool. Almost done. Got 2 more here. This switches gears a little bit. This is where we have our first dilution. If you don't know the word dilution or the word dilute, to dilute something means to water it down. Dilute means... To dilute something means to water it down. So let's look at G. It says when adding water to a solution, the concentration of that solution will, and that should be clear to you that it's going to decrease, right? Because it's changing the ratio of solute to water. So let's think, if we have 1,000 milliliters of 2 molar solution, how many moles of solute is that going to contain? Well, you've already done this. I don't have to ask you. You've already figured that out, that it's 2 moles of solute, right? Because our 2 molar solution means 2 moles per liter, and 1,000 milliliters is a liter, so I must have 2 moles of solute there. When 1,000 more milliliters of water is added, so now we've doubled the volume, the concentration should half, right? Doesn't that make sense? That it would go down to just 1 molar? But what I want to point out to you is that, let's draw a little picture of this. The amount of solute remains completely unchanged. So I'm going to draw my water particles here. There's my water, and actually, I guess that should be my second one. Sorry if I'm confusing you right now. So we're going to have our water, our 1,000 milliliters of water in this beaker, and we need some solute as well. I'll do my solute in, how about this color? Okay. Are we cool with that being 2 molar? I just kind of put a random number of dots. When I add water to my beaker, and then my new beaker looks like this, I'm still going to have the same number of these little red dots. Right? But you can tell that the concentration of my solution has decreased because I have a different ratio of solute to water. The amount of solute remains unchanged. Okay, let's talk about why that's important or why we care about that. There's this formula that we can use to calculate what the new concentration is after we add water to a solution. And that formula is this right here. I'm going to talk more about this in the next video, the dilutions video, but this basically means our initial molarity times our initial volume is going to be equal to our final volume, our final molarity after diluting, multiplied by our final volume. So let's work this example up here first. What is our initial molarity before we add any water? It's 2 molar, right? 2 molar. What is our initial volume? We can see it's 1,000 milliliters, so 1,000 milliliters. And that is equal to, according to this formula, should be equal to our final molarity, in this case 1, multiplied by our final volume. And our final volume, if we had 1,000 milliliters of solution and we added 1,000 more mils of water, 1,000 plus 1,000 is 2,000. So we can see from the example that we already talked about in G that our formula holds true, right? 2 times 1,000 is 2,000 equals 1 times 2,000 is 2,000 again. So 2,000 does equal 2,000. Yeah? So let's use the formula now to solve a different question, and that's this one right here. Calculate the new molarity when 250 mils of water is added to 750 mils of a 3 molar solution. So before we add water, what is the molarity of our solution? It's 3 molar, right? And I'm going to multiply that by our initial volume before I add any water. What am I adding water to? I'm adding 250 mils of water to 750 mils of 3 molar. So 750 mils, that is my initial volume. And I'm saying that that is equal to my final molarity, which in this case is unknown, right? I don't know what my new molarity is, so I'll put a question mark there. And that number, whatever it is multiplied by the final volume. Well, what's our final volume? We started with 750 milliliters, and to that we added 250 milliliters of water. So both of those volumes added together, that's 1,000 milliliters. You see? So now how do we solve for that question mark? How do we figure out what MF is? Well, we can just divide both sides by 1,000, yeah? And if I divide both sides by 1,000 mils, then my 1,000 mils cancels on my right, and I'm left with just MF equals 3M times 750 mils divided by 1,000 mils. So let's do it. 3 molar times 750 divide by 1,000, and I get 2.25 molar. Remember, like I said, there's going to be another video out on dilutions. Probably tomorrow I'll try to get that to you. I might even send it tonight. I don't know. We'll see. But there is that. I know some of you were awaiting that anxiously. So here's your video key. Check your work. Yeah. Let me know if you have any questions. If you need me to go over something again, I'm happy to do that. That's fine. All right. Thanks.